Hey, it's Sami from Math with Sami Montasser YouTube channel. Today, I'm just going to explain to you how to change numbers in scientific notation. So when we have a number like this and we want to change it into scientific notation, let's say something about scientific notation. When we write in scientific notation, now in scientific notation, has to be only one number before the decimal. So we cannot write 72.5 times 10 to the 17. We cannot write that. That's not scientific notation. Only one number before the decimal on the left. So that's how scientific notation is. Now let's go to this question right here, or the first question we have in there. We have this number and we want to change it to scientific notation. So the first thing you need to notice here, or you need to make a note of, there's no decimal here in this number. Okay. If there's no decimal, we always know you could have a decimal here at the end of the number. So let's say it's 0.0, but you don't even need to write that 0.0 n at all. Now, in scientific notation, as we agreed, there has to be only one number before the decimal. Okay, one number before the decimal. So what we need to do, move this decimal 1, 2, 3, 4, 5, 6 to the left. So that becomes 7 point, because the decimal went right here, 0.4. And then we don't need to write the zeros after that in here. Okay, so just 7.04, we just all the numbers that are in there, except the zeros. And then you multiply this by 10 to the power of, and that's what we need to find out. So if you move your decimal, that invisible decimal that's here, to the left, 1, 2, 3, 4, 5, 6, then we have to put a 6 in here. Is it positive 6 or negative 6 that we put here? If you're moving the decimal to the left, like what we did here, the decimal moved to the left 6 places, then the exponent should be positive. All right. Now let's go check out the next one right here. So this one has a decimal already, so we don't have to make up a decimal. But as we said in scientific notation, there has to be a number before the decimal, not 0. So therefore, I have to take this decimal, move it 1, 2, 3, 4, and then it becomes 5.72. We get rid of all these zeros because we're going to represent them right here by 10 to the power of, since we moved 1, 2, 3, 4, and since we moved to the right, we write 4, but it's negative 4 because the decimal moved to the right. So remember now, if we move the decimal to the right, then the exponent should be negative, and we count how many places we moved the decimal to. So here it's 4, so we put negative 4 on top of the 10. If we move to the left, we just count how many places did we move the decimal to the left, and then we write it's positive, and since we moved it 6 times to the left, then it's to the 10 to the power of positive 6. And this is how you change to scientific notation. Now, how about if we start multiplying numbers and dividing them, and we have to express the answer in scientific notation, and that's what we're going to do on the next slide. So when we're multiplying numbers like this, and we want to express the answer in scientific notation. So remember, we have to express this answer in scientific notation. The first thing we need to do is change these to scientific notations first. So now, because we don't have a decimal here, then we know there's an imaginary decimal right here and right there. And this decimal for this one is going to move 1, 2, 3, 4, 5, 6, 7 to the left. So this becomes 4.9 times 10, and since the decimal moved to the left, then it's going to be positive 7 times 730,000. The decimal is right here. We're going to move it 1, 2, 3, 4, 5 to the left. So it's going to be 7.3 times 10 to the 5. How do we express the answer now? The answer is going to be, so this will equal, first of all, let's deal with the 10 to the power of 7 and 10 to the power of 5. So when you multiply 10 to the 7 times 10 to the 5, you could just skip. Then in here, you're going to get 10 to the power of 12. You remember when we multiply the same thing or the same basis, we add their exponents. So that becomes 10 to the 12. And then you just multiply 4.9 times 7.3. You could use your calculator to do that. So 4.9, it's going to use the calculator, times 7.3 equals 35.77 times 10 to the 12. Now, is this answer expressed in scientific notation? No. So what do we need to do to express it in scientific notation? Remember, we have to take this decimal here and move it to the left one, because in scientific notation, as we said, only one number has to be before the scientific notation, and that number cannot be 0. It could be any number, but not 0. So that means we have to move the decimal 1 to the left. So therefore, this will give me 3.577. And since we moved the decimal 1 to the left, then we multiply by 10 to the power of positive 1. And we still have the times 10 to the 12. Now we have 3.577 times, multiplying these, add the exponents. So 10, add the exponents, 1 plus 12 is 13. And that's the answer for this one. Okay, so we'll do 2 more questions. So this involves 3 things that are multiplied, and we have to change all of these numbers to scientific notation. So we don't have a decimal here, so there's an imaginary or invisible decimal here, and we have to move this decimal 1, 2, 3, 4, 5, 6, 7 to the left, and that gives me 2.6 times 10 to the power of 7 times, no decimal, so there's imaginary decimal there or invisible, so 1, 2, 3, we move 3 to the left, so times 7.9 times 10 to the power of 3, since we moved the decimal 3 to the left, times, now here there's a decimal right there, and we have to move now to the right, so 1, 2, 3, so that gives me 4.6, and when we move the decimal to the right, as I mentioned, the exponent has to be negative, and we move 3 to the right, so this negative 3, yeah. Now, since this is 10 to the 3 and that's 10 to the negative 3, we know when we multiply them, you're going to get 10 to the 0, and anything to the power of 0 is 1. So you could just cancel these right away. And then what we do, we have the 10 to the 7 times, take these 3 numbers here and multiply them. So 2.6 times 7.9 times 4.6. And we get 94.484. Now remember, we cannot have 2 numbers before the decimal in scientific notation, so therefore we have to move this decimal to the left 1, and that will give me 9.4484. And they didn't specify here, so you could have as many decimals as you want. If they say round off to 3 decimals or 2 decimals, sorry, then this will become 9.45, but that's a different lesson altogether. And since we move this decimal 1 to the left, then we have to multiply by 10 to the 1, and we still have the 10 to the 7 right there. Now this becomes 9.4484 times 10 to the 1 times 10 to the 7. You add the exponents and you get 10 to the 8. One more question. So now we have 2 things that are multiplied and then divided, everything divided by 12,800,000. So again, we have to change all of these to scientific notation, and all of them don't have decimals. So all of them, they have imaginary decimals at the end. Yeah. So here we're moving the decimal 1, 2, 3, 4, 5 to the left. So that becomes 3.2 times, I said 5 to the left. So 10 to the power of 5 times this one. We're moving 1, 2, 3, 4, 5, 6, 7, moving them 7 to the left. So 6.4 times 10 to the power of positive 7, since we're moving the decimal to the left. And here also we're moving the decimal 1, 2, 3, 4, 5, 6, 7 to the left. So this becomes 1.28 times 10 to the 7. Now it's always, since all of these are multiplied, you could reduce now fractions if you want. And why I want to reduce, because I have 10 to the 7 here and 10 to the 7, I'm just going to cancel them right away. And therefore, what I have 10 to the 5 on top times 3.2 times 6.4. You get 20.48 times 10 to the 5 all over 1.28. Now what I'm going to do, I'm going to take these two numbers right here. And since it's a fraction, you know, you could divide these two numbers, eh? So I go 20 times 20.48 divided by 1.28 equals, and you get 16. So this equals 16 times 10 to the power of 5. Of course, we cannot have 16 times 10 to the power of 5, because that's not scientific notation. Remember, in scientific notation, only one number have to be before the decimal. And we know we have an imaginary decimal right here, so we're going to move it to the left. So that's going to give me 1.6. And since we moved the decimal to the left 1, we multiply by 10 to the power of 1. And we still have the 10 to the 5. And this will give me 1.6 times 10 to the power of 6 as your final answer. So here's the other question. Here we have 500,000 times 0.0079 times 0.00046. We don't have a decimal here, so there's an invisible decimal right here, and we have to move the decimal 1, 2, 3, 4, 5 to the left. So we're going to get 5.0 times 10 to the power of 5. Since the decimal moved to the left, then the exponent should be positive, times this decimal is right here, so we moved 1, 2, 3 to the right. So that becomes 7.9 times 10 to the negative 3. Since we moved 1, 2, 3 to the right, this decimal has to be moved 1, 2, 3, 4 to the right. So that becomes 4.6 times 10 to the negative 1, 2, 3, 4, we said, so to the negative 4, since the decimal, we moved it to the right. Now here, we got to multiply those numbers, 5.0 times 7.9 times 4.6, 5 times 7.9, whoops, 5 times 7.9 times 4.6 equals, and that's 81.7 times, now here we have 10 to the power of 3 times 10 to the power of negative 3 times 10 to the power of negative 4. So we add the exponents, so 5 plus negative 3, that gives me 2. 2 plus negative 4 gives me 10 to the power of negative 2. Is this scientific notation? The answer, is it in scientific notation? No, because as we said, we have to have only one number before the decimal. So this decimal here has to move 1, 2 to the left. So this becomes 1.817 times 10. Since we moved the decimal 2 to the left, that becomes 10 to the power of 2. And then we still have 10 to the power of -2, which gives me 1.817. And 10 to the power of 2 times 10 to the power of -2, you get 10 to the power of 0 when you add the exponents. And anything to the power of 0 gives you 1. So this becomes times 1, and anything times 1 will just be itself. So 1.817 times 1, just 1.817. So we don't even need to write that 1 there. And the answer here, that's how it's expressed. You don't have to write 10 to the power of 0. But this is our final answer as far as this one is concerned. So there it is. That's how we do scientific notation. I hope you learned something from this. Don't forget, our channel, Math with Sami Muntasser, supports kids overseas, specifically in Libya. It's a war-torn country. Kids need something to be hopeful about. And I have decided long ago that I'm going to give 10% of the earnings on my channel to help kids sports in Libya. So what a best way, or what a better way to help kids have a smile on their faces than getting them to play the sport they love, which is soccer. And that's what where my contributions go. I gave 10% of the earnings on my channel last year, and I'm planning to do that every year. So next year, the contribution will be even bigger because my channel is growing. And it's only with your support that's growing. So keep on supporting. As always, thanks for your support. Till next time, bye-bye.